Okay, angles of polygons. First of all, we need to name some polygons, and we're going to make kind of a chart here. What is a polygon? Well, a polygon is, for instance, there's one, the smallest one is called a triangle. A triangle is a polygon. The next one, quadrilateral. Anybody know what the next one is? Pentagon. Let's go to another one. Hexagon. We'll stop right there for right now. How do I classify these? What separates one from the other? Number of sides. And this is usually denoted with the letter N. How many sides does a triangle have? How many sides does a quadrilateral have? How many sides does a pentagon have? How many sides does a hexagon have? Okay. Some of the interior angles. Well, do you know what the angles inside a triangle are supposed to add up to? How about a quadrilateral? You don't know that offhand, do you? How about a pentagon? Don't know that? These. Let's talk about an n-gon. Now, here's the deal. It has n number of sides. And it turns out that the sum of the interior angles will always be n minus 2 times 180. If you look in the book, this has to do with how many diagonals you can draw and therefore how many triangles are in. By drawing the diagonals, if you look at these pictures they have right here, we know the angles inside of a triangle add up to what? 180 degrees. Now, you cannot draw a diagonal in a triangle, so there's just what? 180 degrees in here. However, a quadrilateral, you can draw one and you can make how many triangles? 2. So there's 180 and 180. Guess what their angles add up to? A pentagon, you can draw 2 from one point. How many triangles you make? 3. Guess what theirs is? 540. Hexagon, guess how many you can draw? 3 from one point. So there's 1, 2, 3, 4 triangles. Okay? And if you'll notice, how many diagonals you can draw from one point is always however many sides there are. 5 minus what? 6 minus 2. 4 minus what? 2. 3 minus 0. Or I'm sorry, 0 minus 0. So, I'm sorry, n minus the number of 3's. Well, anyway. Okay? That's how you get m minus 2 times 180. So when you put that in here, and this is something you guys need to remember, it would be 4 minus 2 times what? Which is what? And these are all the angles inside, what they add up to. Pentagon would be what? 5 minus 2 times 180, which would be, what'd you guys find out? And then a hexagon would be what? 6 minus 2 times 180, which would be what? 720? 180 each time, yeah. What if you had a regular polygon? What does it mean to be a regular polygon? We have talked about this. It means all the sides and angles are congruent. So we could find the measure of each interior angle of a regular polygon, of a regular triangle. How do you think I'm going to do that? If all the angles are equal and they have to add to 180, what would I do? Okay, all the angles inside of a triangle. Everybody look up here. You can write this down in just a second. All the angles inside a triangle add up to what? How many angles are there in a triangle? If they're all equal, what am I going to do? Divide the total and divide by what? How many there are. So each interior angle in a regular triangle, each interior angle has to be what? Now the key here is we're only talking about what kind? Regular. We can't find it for non-regular because it could be, we could have one that's what, 40, 50, and 90, right? That would add up to 180, but they wouldn't be regular. A regular quadrilateral. Well, what do I do here? Divided by how many angles are there? What do you get? So we're talking about each interior angle of a regular polygon now. For a regular pentagon, what would I do? 540, and I would divide by, what do I get? 108 degrees. Let's talk about a regular what? Hexagon. I would divide this by what? 6. What is 720 divided by 6? 120. What would I use as a formula? What am I doing every time? I'm taking the total, which is m minus 2 times what? 180, and then what am I dividing by? The number of sides, which is, so that is your formula for finding. This is only a what? Regular polygon. Important to remember that. Make sure you have that written down. One of the nicer things, and I promise you, on every EOI test, there's a question about this on there. You really don't deal with this very much, but for some reason, there's always a question on there. There's a nice thing that happens with any polygon. The exterior angles of any polygon will always add to 360 degrees. Period, 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 period. Now, I'm talking about exterior angles. What are exterior angles? Yes, but how do you make one? What do you do with the side? You what? Continue it on, and you kind of go all the way around, right? Real quick, I'll let you write it down in a second, but first look at this. Aren't these all exterior angles? See how we're extending on here on the right? 105, 40, 105, 110. Guess what they add to? 360. 120, 100, 140. Guess what those add to? So on and so on. Guess what those add to? Now we're talking about the exterior angles going around the same way. You know, if you were to extend the opposite direction, all those will add to 360. Because you know how you can kind of extend each direction? But it doesn't matter. They will add to what? 360. Period. So with regular polygons, you should always be able to find what the exterior angle is, correct? It's always going to be the other side of 180 degrees, isn't it? Of the one you have and the interior. So here the exterior angle is 120, right? And you got three of them. Guess what 120 times 3 is? 360. The exterior angle of this one is going to be what? 90. What's 90 times 4? What's the exterior angle of this one? 72. What's 72 times 5? 360. Guess what the exterior angle of this one is? 60. What's left out of 180, right? What's 60 times 6? 360. Works out every single time, doesn't it? Now, what type of problems are we going to do in this section? Well, you can bet we're going to have a lot of equations, things where we have problems where we're going to have to say this, this, and this add up to, well, it's a pentagon, so the angles would have to add up to what? 540. Then the next problem might be a quadrilateral where we give you all the angles. Well, guess what they have to add up to? 360. But then there might be a pentagon where we give you all the exterior angles. You know they have to add up to what? 360, because exterior angles always add up to what? 360. So we'll give you problems to test whether you understand or have to reinforce information given. Of course, there'll be a couple of easy ones like this. I'm on page 72. Where we simply say, find the sum of the measure of the interior angles of this convex polygon. 11 gone. Interior angles, right? The interior angles are what? What's the formula? M minus 2 times 180. That's what you have to know. How many sides do I have here on number 1? 11. So what would my formula be? 11 minus 2 times what? If I don't see that, it's wrong. Why? Because I want to make you write down this, in essence, over and over again, so you'll maybe what? Remember it. Remember, this is education, not get my homework done class. Okay, there's a difference. I want you to, but how long did it take me to write 11 minus 2 times 180? 2 seconds maybe? I'm not asking a whole lot, so I don't want to hear any whining about it. I want to see 11 minus 2 times 180. I want to make you write this formula down as many times as I can. Why? Because you'd be amazed at when we go start doing things where we've got to refer back to this information, chapter 8 stuff and 7, which gets really, where we're dealing with, after we do trig functions, but we're having to remember how to find the sum that we forget this. So this is something I want to see. It's not too much to ask. The rest is calculator work, isn't it? You don't have to show all the steps here. Now you just put what? 9 minus 180. What do you get in your calculator, guys?
Where do you get the minus from?
N minus 2 times 180 is the formula. Can no one put 9 times 180 inside their calculator?
1,620.
1,600 and what?
20.
Okay. There's your answer. This is exactly what your paper should look like on a problem like this. You should have, number 1, that written down, then that, then that. Not hard. But you have to listen in class and hear me say it. Watch the video again. I want you to reinforce this formula. I want to see you write it down. Here. What am I going to write? Prove to me you know what you're doing. Now, the rest is calculator book work. I'm not going to make you write 12 times 180. I mean, I think you know that 14 minus 2 is what? 12. Okay, that's not what I need to see. What I need to see is you know what? N minus 2 times what? 180. That's what I'm reinforcing. Back in the old days, I didn't have to explain why so much, but it seems like you guys really want to hear it, so I'm telling you why. I want to see you write this down over and over again. Now, what is 12 times 180? This is how it should look on your paper. And that's pretty easy, isn't it? Now, find the measure of what? Find the interior angle of a regular polygon. Find the number of sides in the polygon. Well, guess what here, guys? This isn't easy. That's the equation you have right there. Number 4 on page 72. Okay. This is kind of I would say, kind of a difficult problem to solve. But look up here, and I expect to see this work shown. Every time, this is what the interior angle of a regular polygon should be, right? This is equal to n minus 2 times 180 over what? N. Cross multiply. What are you going to get? 144 what? Is equal to n minus 2 times what? 180. When you multiply through, you get 144. N is equal to what? 180n minus 360. Add 360 to both. Or no, I wouldn't do that, would I? Best thing to do would be subtract 180n. And I would get over here, I would get, what is negative 180 plus 144 would be a negative 36. N is equal to a negative 360. Divide both sides by negative 36. You get N is equal to a positive what?
10.
So it's a 10 gon, decagon. Write that down so you have that, so you know how to do one of these problems. Step by step. Write every step. I will. Sorry, this is 144. I will unfreeze it. Does everybody follow what we did right there? Mm-hmm. On the last part? Yes. I divided. Remember, anytime, whatever's in front of the n, you know, like if you had 4x equal to 12, you divide both sides by 4, right? Well, we had negative 36n is equal to negative 360. And we don't want to know what negative 36 n's are equal to. We want to know what one of them are, so to make it into a 1, we divide by itself. It just, with the negative dividing there, you're thinking subtraction, but we're just dividing by a negative. Common mistake. Good question. Has everybody got that down? Yes, ma'am. What we did here is I went 180 times n and 180 times negative 2. You're used to this 180 being out in front, aren't you? You know what I mean? I just distributed through, because negative 2 times 180 is a negative 360. Makes sense? But you guys are used to seeing that out on the other side, so that's probably what maybe threw you a little bit. Good question. We good? Everybody got it down? Okay, let's look at number 7. Number 7, first of all, find the measure of each interior angle. So they want to find the measure of angle what? J, the measure of angle K, the measure of angle N and the measure of angle M. But to do all that, I have to find what? Before I can do any of that, what do I need to know? What x is, right? Now, basically, I know that these angles have to add to something. 2x plus 15 plus what? Plus what? That's the other angle. And the last angle plus what? All of these have to equal something. Well, if you don't know it already, use what? N minus 2 times 180. How many sides does this have? 4 minus 2 is 2 times 180 is? So I know that all of these angles have to add to what? 360 degrees. All these interior angles. Now, the next problem we do could have a pentagon. That number's going to change, isn't it? If it's a triangle, that number's going to change. Now, it turns out, and everybody, guys, I'm going to freeze this up. This is the last one we're going to do. So everybody, or actually I'm going to do one more, but I'll put it up here, so please just pay attention. Over here, is anything going to change in our equation? How many sides does it have? 4. So what do our angles, all interior angles, all add to? 360. So for these two, it's not going to change, but I bet there's going to be some on your homework where this is like a what? A pentagon, or a hexagon, or an octagon. Okay, where you're going to have to put it into the formula. Now, at this point, it just becomes a big, ugly equation. Now, when I taught algebra, I always said if it's big, it's ugly, it's confusing looking, what probably needs to happen in this equation? There's some simplifying to do. There's a reason why it looks not simple. It's because it's not simplified as much as it can be. There's a much simpler way to write this, and the simpler way is to, well, let's combine all these x's. You have 2 x's, 3 x's, and 1 x and another 1 x, so you have a total of 2, 5, 6, what? 7 x's. Well, there's also a simpler way to write 15 minus 20 plus 15, isn't there? 15 and 15 is what? Minus 20 is? I don't know about you, but that's a much simpler way to write all of that. Agreed? And that's why we call it simplifying. Now, from this point, now it looks like a normal equation. Pretty easy. What are we going to do? Subtract 10, 7x is equal to what? 350 divided by 7. What does x equal to? Now, this one came out nice and even. Don't think you're necessarily wrong if it doesn't come out, if you have a decimal sometimes. That will happen. But you're right to maybe look at it again and make sure you didn't make a mistake, but don't just assume you're wrong. Now, the thing about it is, and I would hate for you to go through all of this and not get the problem right. What did the problem ask for? They asked for all of these angles, correct? Well, does x represent any of those angles? Which one? M. So the measure of angle M is what? And you know what helps me? What did I do that's going to help remind me what they're actually asking for in this problem? I put it right here what it was and left it blank, didn't I? That kind of helps remind me. Because I'm going to have to write that anyway, aren't I? At some point. I can't just say this, 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 and this. I have to say what this angle is, what this angle is, and what this angle is. You have to communicate. So, for instance, angle J is 2 times whatever x is. And this is where, I can see skipping steps. 100 plus 15. What do you get there? 115. Here, 3 times 50 is what? 150 minus 20, so K is what? 130. X plus 15, that'd be what? See, this is where I'm okay with you skipping some steps and kind of just throwing stuff in there and doing calculator work on that. Because you understand the concept of this problem, don't you, by doing this? And that's what we're teaching in the new stuff we're learning. Now, the last problem, before I zoom out and let you copy this down, don't copy that down yet. It says find the measure of the exterior angle of an interior angle given the number of sides of each regular polygon. This is so easy, isn't it? This has 16 sides, and they want to know the what? Exterior angle. And they say that it's also what? Regular. So that means all the interior angles are the same, right? So what are all the exterior angles going to be?
The same.
The same. So I know that the exterior angles, no matter what, no matter how many sides there are, they always add 2. So if I just divide that by the number of exterior angles, which will be the same as the sides, 16, well, I get some number here. 8 will go into that 2, and 8 will go into that. I think 16 will go into that evenly, won't it? What do you guys get? Huh? 22.5? So you think we can do that? All right, I'm going to zoom this out so you have kind of everything there, and I will write down your assignment. We will do numbers. We don't ever do these as homework. 1 through 4, 6 through 19, and 30 through 33. Write problems, draw figures, show all steps and work. Due at the end of the hour, Wednesday, 12 to 15. That may be different than what's on Canvas, but I'll change it right now.